So let me put up the answers real quick, and then I'm gonna have you all, well, I'll just write them up. Okay, so you should have
So were we supposed to do F and G? Alright. This is that D wrong.
all right, who got 7 out of 7? Who got at least 5 right? All right, let's go through them real quick. So what I usually do, I'm looking at the number, and I'm noticing that these first 3 are asking me for the limit at 1. So what I like to look at is, well, what's happening on the graph at 1? Nothing. It doesn't have a jump. It's not even a removable, it's a point. A removable would be an open circle. There's nothing happening there. So there is no reason why I wouldn't have a limit at x equals 1. At x equals 1. So if I look at it from the left side and for the right side, if you draw a line, the left side is hitting this green wall at 3. The right side hits the green wall at 3. And because they both hit the wall at 3, that means we have a limit at 3. Yes, Deborah? We're going to do a whole lot of examples. All right, number 4, or D, letter D. So for that one, it's saying -5. So -5 is right here, and that's a jump. Jumps don't have a limit. Also at +5, we have a jump. Both of those places are a jump, so we don't have a limit. For F and G, you're going to look for the closed point. I'm good.
If there's a jump. Focus on the closed one.
You do?
Okay, the closed circle then. Just focus, if you see a jump, then focus on the closed circle next to your right eye. But you're not actually finished. Like, look,
I have one now.
And then there's an open circle, and then there's a closed circle. So focus on the closed circle, and then it's 2.
No, still. Because there's
So
2
why-
points on the line, there is no one point that you can focus on. You can't selectively ignore you can't ignore the removable. It's
So
still.
why are 2 and not D and E?
Are you looking at G or are you talking about?
F and G.
Right. That's something else. That you do
Okay.
focus, for that you do focus.
So for question F, we have a closed point. My closed point is here, which is why my answer is 0. And for question G, my closed point is here, which is why my answer is 2.
You're right.
Yes.
I get that actually.
We're just talking about different things.
Jumps don't have a limit. Now, if it asks me for and we're going to do some like that. We are going to do a whole lot more today. We're going to do 29 more. So, all right. Before we do that.
Pardon the interruption. At this time, we will begin our first lockdown drill of the year. Once again, this is a drill. Teachers, please close and lock your classroom doors. Ensure all students are accounted for. There should be no passes, written in hallway movement. It should cease until the drill is complete. Once we finish our drill, I will let you all know. Thank you.
All right. So now let's go to our notes. For our notes, we skipped example 1. So take out your note packet. There's a stapled packet, like 3 pages.
Yeah, I think I have it.
Okay. So let's look at these. How are we going to do it if it's an equation? We skipped this yesterday. So when you have an equation, we're going to look at what is x approaching. And in this example, x is approaching -4. So we're going to substitute that -4 in the function where there is an x. So I'm going to rewrite this. So this would be 2 times -4 plus 8 divided by negative 4 minus 9. Go ahead with your calculators. See what you would get. This is the note packet. So yesterday you picked up 3 handouts. You picked up homework, notes, and a practice sheet. And we're doing number 1 in the notes. It should be right at the top of the page. At the very top. We skipped that yesterday. All right, so pick up your calculator. Take 2 times negative 4 plus 8. And divide that by negative. Can you hold that question, please? Okay. And then divide that by negative 4 minus 9. And negative 4 minus 9 would be negative 13. So what is 0 divided by negative 13? If you are actually type that in your calculator, do you get an error? You get 0. So that means that my limit at that point in this function, my limit is negative 4. Yep, exactly. Good. That's exactly what it's saying. When x approaches negative 4 or at negative 4, the limit or the graph is at 0. All right, now let's move on to part B. We're going to substitute in a 2. So substitute in 2. So that would be 2 squared plus 3 divided by 2 squared minus 6 times 2 plus 8. All right, use your calculators. They just have to check and make sure all the doors are locked.
Forgot we were on lockdown.
All right, so what's 2 squared plus 3? 7. What do you get when you take 2 squared minus 6 times 2 plus 8?
0.
Type that in your calculator. Get an error. So that means that the limit does not exist. There is a discontinuity happening right there. That's why we have an error. Yes, because it's impossible to divide a number by 0. So you can have a 0 divided by something. So like in part A, see how our 0 was in the numerator? That's okay, but we cannot divide by 0, so that does not exist. All right, try to do C by yourself. Plug in negative 1. All right, go ahead and type that in your calculators. Did you get positive 2/5?
No.
What'd you get?
I think I just put it in wrong.
Yep, that's probably right. Or a decimal. If you got a decimal, you would get 0.4. Did you get 0.4? Okay, so type it in again.
Oh, I forgot my parentheses.
You got to put parentheses around the negative, kids. You have to. So your limit would be 2/5. Yes.
Question. Okay, so I put parentheses. I didn't put parentheses over this squared.
You have to put the parentheses around the square. You have to, because if you don't, so did you type it in like this?
No, I'm trying to do mental.
Oh, okay. So if you're doing mental here, what is negative 1 squared?
It's 1.
1. And so 1 minus 1 would be 1 plus negative 1 is 0. 0 minus 2 is negative 2.
Yeah, I did, well, first I did negative 1 together with -2 after I squared -1. I still got the same answer.
Okay. So now so what did you get?
I got the same answer.
Okay.
I just,
Wait, what did we just say?
We only have 40 minutes. Literally, that's all we have. All right, let's look at D.
Yeah, how do you do that?
So this last one, I'm going to touch on it briefly.
At this time, our drill is complete. Teachers and students have a great rest of your day.
Now we got a lot of interruptions. That's why I'm not trying to ignore you all, but I have to kind of get through what I need to get through. Okay, so I'm going to briefly talk about this, and if needed, I'll come back and we'll talk about it more. But this is kind of going back to Algebra 2, which we may not remember because that was a few years ago. But just know that this number, which is called your leading coefficient, and we're going to talk about this a little bit in 4.1. This controls the right arrow. And what this question is asking you is, what is your right arrow doing? That's what this, whenever it says x approaches positive infinity, it's asking you, well, what is your right arrow doing? And in this example, because it's positive, I know that on the right, this graph is going to go up. This is actually called end behavior, which again, we'll talk about again later. So the answer would be positive infinity. Okay, so now I want you to go to the last page of the notes, the very back page. I want you to do numbers 1 through 10, and then put your pencils down so I know you're done. And I'm going to give you the answers. So let's see how many we're getting correct on our own. On the back, the last page in your notes. No, the notes. So go to your notes packet, go to the back. Yeah, that one. That's it. Oh, yeah. No, it doesn't matter. I mean, I do want you to start challenging yourself to see if you can, I am going to give you a sheet like that tomorrow with 29 questions that you're going to do with your notes. And I'm just going to collect it and grade it and give it back to you. All right, so take about, it shouldn't take you more than 60 seconds to do 1 through 10.
am I on the right page?
Mm-hmm.
Okay. 1 through 10?
Mm-hmm.
Okay.
So just 1 through 10 for right now.
Are we going to talk about the true or false in the whole?
Can you see
Just hold it up. Let me see. What is it? Can you read it to me?
the last two?
It says, yeah, so that's saying like, do you have a discontinuity between those intervals?
Okay.
No, I wasn't gonna talk about that.
I didn't understand the question.
Oh, yeah, so it's asking you, this says, does it say if it's continuous?
Exists for every, what's
Yeah.
the limit of f of s exists for every c in the interval?
Yeah, so do you have a discontinuity between those two?
Those are both x values, right?
Yes.
Okay.
And as long as you don't have a jump or an infinite, then it does have a limit.
Could you tell us which ones we look at for the close-up
Oh, wait, does anybody need more time before I show the answers? All right, let's go ahead and grade our answers and see what you did. And then we'll talk about them. And then I'll explain them. So for the first one, I started off highlighting and then I stopped, but where it says -5, the first thing I do is I look at the graph at -5. And when you look at -5, when you look at x equals -5, that would be right here. What's happening right here in the graph? What kind of discontinuity do we have there? Is it a jump or is it a removable? Who says it's a removable? It's a removable because there is a hole in the graph. Remember, removables have a limit. Removables have a limit. The other thing to keep in mind is that these three questions are talking about the graph. And this question is asking you for the point, closed point. So that's why for 1, 2, and 3, because my graph is at +2. And that's why I had a +2 for my first 3 answers. And then the point, though, was at +1. Yes.
So the picture of jump is two functions, like is that solid with a flat line?
So actually, I think our next question, Deborah, is a jump. So when we look at 5, 6, 5, because they all kind of go together. 5. Wait, let me use green. Okay. 5, 6, 7. So now when I look here, do you agree that right here, where I highlighted it in green, that is a jump? The graph is not, the graph is not connected at that point. So when you look here, do you agree that the graph is connected? But here, see, the graph is not connected. This open circle and this open circle are not connected. This is a jump. So that's why the answer to 7 does not exist. For number 5, I'm looking at the graph. If I draw a line here, I'm asking, okay, where does the graph touch my green line on the left? And on the left side, it touches it here. And on the right side, it touches it here. They don't touch at the same place. That's a jump. So that's why the answer to number 5 is where my red point is. And the answer to number 6 is where I put my blue point. And because they are not the same, 7 is D and E. So these 3 are asking about the graph. Now I have the erased. And this last one is saying, where is the closed point? and I have a closed point right here, and that's the answer to number 8.
Did I say that 7 is asking for discontinuity? Or just a graph?
I didn't hear you. Can you say that one more time?
Is 7 like asking for discontinuity?
Nope, it's asking you for the limit at that point. And if it's a jump at that place, it does not exist. Yes, Kimmy.
Okay, so for question 5, why was the answer -1 and not 4?
Okay, so right here, if I draw a green line, do you agree that the graph on the left side of that green wall touches my green wall right here? That's -1. And then on the right side, it touches here. And that's +4. It touches it at 2 different places, which is why it does not exist. All right, 9 and 10 is talking about 0. 9, 10, 11, and 12, I think, actually. But we'll just do 9 and 10. When I look at the graph here at 0, you see where I have my little laser? Do I have a discontinuity happening right here? No. So the limit from the left and the right is 6. All right, I'm going to give you a few minutes, and I want you to finish it. I want you to do 11 through 29. 11 through 28. I'm not really concerned with 29. All right, do 11 through 28. I'll put up the answers here in a second. So we're doing 11 through 28. Anybody need more time? Okay. So you're going to go all the way through 28. Make sure you go all the way to 28. All right, so just because I want to make sure we have enough time to see your tests and talk about retakes, go ahead and start grading numbers 11 through 20. Just circle the ones you miss. So I'll read them off. So 6 for 11, you should have 6, 6, 7, 4. 15 does not exist. Excuse me. 16 is 7. 17, 18, and 19. Okay, Sam. Are you a little frustrated with your answers? Okay. 17, 18, and 19 are all 2. And 20 does not exist. Did you break your pencil in half? You got to, okay, get you another pencil. Let me get you another pencil, because I don't want to stress you that bad. It's okay. It's just late. All right, let's talk about them real quick. So at 11 and 12, we don't have a discontinuity. So it's just 6. So let's look at 1. At positive 1, we have a jump. So on the left side, the graph is hitting here, which is why 13 is 7. The right side, these two are not connected. So that's why 15 is D and E. So this point is 7, and then it jumps down to 4. And then for number 16, the answer is 7, because that's where we have our close point. When we look at 17, 18, and 19, we're looking at the graph at 3. And right here, we have a hole in the graph. That's a removable discontinuity. Removables have a limit, and that's why the answer is 2. 20, though, is D and E, because there is no closed point along this x equals 3 for me to look at. And that's why 20 is D and E. For number 21 through 24, we're looking at the graph at x equals 4, which is right here. We have another jump. The left side is touching this blue line at 1. The right side is -4. They're not connected. That's why 23 is D and E. We do have a close point. So for 24, the answer is 1. And then at 5, that's this pink line. On the left side, which is right here, that would be at -3. On the right side is at +1. These are not connected, so it's D and E. And for number 28, the answer is just 1.